Today we're going to be talking about the steps of the scientific method. The scientific method has a series of steps that are used to investigate a natural occurrence. In other words, it's a process of experimenting that we use to explore our observations and answer questions that we might have. The scientific method is a guide to help you through your experiment, help you through making your observations and answering the questions that you might have. It's not always exactly the same every time that you have a question or want to do an experiment. So you have to remember there has to be some flexibility, but it is a guideline. In most cases, the steps to the scientific method are observing a problem, developing some kind of question, coming up with a hypothesis or an idea of what you think might happen, a plan or a procedure of what you're going to do to test it, the actual experiment or the lab, analyzing your data to see what it tells you, and finally coming up with a conclusion about your scientific experiment. Number one, the problem. It's what do you want to know? I thought, my garden looks kind of strange because some plants are all different heights. They don't look right. I just don't understand it. It's a problem. Step number two, the question. What do I want to know? Well, it looked really strange. I want to know, why is one plant growing taller than another? I planted them all at the same time. I just don't understand why one is much taller than the other. Step three, hypothesis. It's when I'm going to predict the possible answer to my problem or my question. So I think if the soil temperature rises, then the plant growth will increase. So maybe some areas of my soil are getting hotter than others, and so maybe those plants are growing taller. Number four, the plan or the procedure. I need to develop and follow a series of steps to complete my experiment. I have to have each thing measurable. So I'm thinking maybe if I set up the plants with thermometers in the soil around the different plants, that maybe I could read the temperature of the soil and record the data throughout the day, week, and maybe even month to see if that's making a difference. Number five, experiment, or sometimes we call it the lab. Follow your plan to test your hypothesis. So I'm going to set up my thermometers in the soil around different plants. I'm going to start recording the data. I might want to do it hourly. I might want to do it daily. I have to come up with that in my plan, but I'm actually going to do the experiment of measuring the temperature around each plant. Step number 6. Now I want to read all those temperatures that I wrote down. I want to make some charts or graphs. I want to look at all the data to see what it tells me. I want to make sure that I'm explaining the results in clear sentences that refer back to my data. And finally, number 7, the conclusion. Make sure you include a statement that accepts or rejects your hypothesis. I found that the temperature of the soil did not seem to affect the plant's growth. Or I found that the temperature of the soil made a big difference on my plant growth. And then go on to state the reasons. What did you find in your data that supported your conclusion? Make sure that you're thorough and back it up with data. So in review, we started out by observing that there was a problem. We observed something that we didn't understand. Next, we wrote a well-defined question that addressed that problem. Next, we wrote a testable hypothesis, making sure that it could be tested. A hypothesis has to be testable. Number 4, we made a plan. We wrote down all the details that we would use step by step, clearly and concisely, how we're going to test our hypothesis. After our plan was well written, we did the experiment or the lab. We tested what we thought might or might not happen. As we were testing, we did gather all our data. After the test, we evaluated, interpreted, and analyzed all the data. We looked at the evidence that we found when we did the experiment. Finally, we critiqued what we did. We came to a conclusion. Were we right? Were we wrong? Did it not make any sense? If we weren't right, okay, was there a logical explanation for why it wasn't right? We might want to go back, rewrite our hypothesis, and start from there again. Remember, this is not always a start-finish. It's a continuous cycle that might need to be tested over and over again to make sure your results are accurate.